sorry. I'm not using Zoom Enterprise. So we are not using Zoom Enterprise. Yes. I would have preferred this meeting over Teams anyways. I mean, Teams has better and time than what's it called? Than Zoom. But let's just quickly go ahead. Let me not take our time. So probably let me give a few seconds for other people to join us before I just go ahead. So Linux is an operating system, like I've said before, much like any other OS. I mean, all thanks to Linus Torvalds. He's the same guy that invented Git. Linus Torvalds is the same guy who invented Git also. Um, oh, he's the same guy that invented Git anyways. So at, as of 1991, I mean, he was able to run the Bash, run against shell. Today, Linux is found on so many home and smartphones. You see, Android is basically Linux. Any Android OS you see today is based on Linux. Everything is based on Linux. That is why you can connect your Android OS to your laptop. And with the right technical expertise, you can do a lot on it. I mean, I can do a lot on my Android phone, but I can't do so much on my iPhone anyways if I connect to my laptop, except when I have to install extra tools. But again, Linux is based on, I mean, a lot of smart TVs, smart refrigerators, they're all based on Linux. Migo, Moblin, network appliances, network devices, Cisco routers, load balancers, desktops, servers, airports, aviation industry. A lot of them are based on Linux. I mean, quite a number are based on Windows, but Linux accounts for over 90% of the servers on Earth. So give it up for Linux. So Linux is usable in every area that Microsoft Windows is, and even many more. And we want adding even, and many more. So yes, it is essential that you know Linux. So I would have loved to go deeper into Linux today, talking about Linux file system, permissions, modifications, user management, groups, file permissions. So everything about Linux is about files. If we go into Linux info, we'll talk about everything as a file. That is what Linux is. Linux is everything as a file. Files and file system and permissions. That's what Linux is about. Everything is about file system and permissions. That's why you need to, I mean, well, so let me not go deeper into that. So Linux is all about file system and permissions. So, and simplicity, handling configuration files in text format, such that everyone or everything is reusable and understandable by anyone who ends up inheriting or who ends up taking over certain systems. So again, moving forward. So we have basic principles of Linux. We have the first principle is everything is a file, like I just mentioned. Everything is a file. The my user account on the Linux system is based on the directory structure. So I would briefly show us later. I'll just open my WSL, and I mean, some of us should already be used to it, but I can open my WSL and show you as my current user, I am located in social directory. So the files located on my directory as a user is only accessible by me as a user, excepting there's an admin level or an admin user who has what's it called, authority over every file system on the particular Linux machine. So which means I can create multiple users on the particular Linux machine and give those users certain accesses to certain directories and no accesses to other directories. So that is why we say Linux, everything is a file, and with file comes permissions. So remember, we have root and sudo. So we also have root and sudo users. That's something we will get into subsequently before we go in deeper into containers. But before then, I would like us to have our own Linux setups. So that is why I will share you guys a text file that you will use to set up virtual machines on your local and practicalize before your next session with me. So probably the next session you have on DevOps won't be with me. So, but your next session with me, definitely you're going to have to do something technical. Left technicality. So I would need everyone set up before them because we don't have sufficient time to set up over this call. Setting up on DevOps can be time consuming, but that's why there's a lot of automations available. You are not going to download virtual machine images yourself. all you need to do is to download automation tools to make that bootstrapping very easy and straightforward. Now, Linux principles, second one, small single purpose programs. We have different programs on Linux. We have programs for listing, for grepping, that's text manipulation and the likes. Small and simple. You don't have to, it's not bogus. You have programs to manage users. You have programs. So everything about Linux is just straightforward. You have binary files to manage different set of system level configuration. Ability to chain programs together to perform complex tasks. Today, I can decide to say, okay, I want to chain two programs together. So let's say I want to list and grep. So I want to list everything. So how do I do this now? I would have loved to practically show you. I mean, and some of you should be used to this, but let me just show everyone. Let me see if I can share another screen. Let me see if I can. Okay, I'll do that after the class. So when we say chain programs together, I can start to say, okay, list ls files in this directory. Then grep me the file starting with E. That is me chaining two programs together or chaining two functions together, listing and grepping. I can start to say, okay, list the files in this directory for me, grep me the number of files that start with A or E, then filter and give me the number. Don't show me the files now, just give me the number of files that start with E. So that's chain commands. You're not talking about AWK manipulating text using bash. It's all the simplicity of Linux that makes that possible. Avoid captive user interfaces. So this core principle behind Linux is more like, let's not use user interfaces. A lot of user interfaces like Windows, like your Windows OS, which can be very limiting because, I mean, with user interface, you don't get to have, should I say, that OS level command over the whole system. You are more limited to what is available on your UI. But with Linux, using the terminal, you're able to invoke commands that can affect, I mean, so long you have the right permissions. So again, they would say the Linux kernel is very, very important because I'm going to show you the Linux architecture very shortly. The Linux kernel is very important, and a normal user should not have access to the kernel. Only admin users should have access to the kernel. But one thing about Linux is that a normal user having the right permission can cause kernel level destruction on the Linux system. So that is where permissions and role-based access control comes in when you are a Linux administrator. However, the concept of Linux is about files and permissions. So anyone can invoke so many commands within the confines of the permissions available or defined for that particular role. So everything. So when you go further into DevOps, when we're talking about DevSecOps and the likes, when we are digging deeper into management of configurations and management of systems, we'll deal more into role-based access control, where we say you are a user, you are a DevOps engineer, you are a software engineer, you are a product manager. You should have view access, write access. Again, we'll also deal with that. I mean, the concept behind ROBAC, we'll also show it briefly on Linux file system. We'll talk about 146 or 126, yeah, 124 actually, where one is executable, two is yeah, 126, yeah. So where one is executable, two is write, and the other one is read, four is read. So when you now say that you are giving this particular directory 77 permission, chmod 777, that means that the first user have read, write, execute, the second one has, the groups have read, write, execute, and every other user has read, write, execute on that particular directory or file. So these are many more ways where how we manage like accesses, but these are just talks till we start practicalizing. So that is why I would need you guys to actually set up what it's set up ahead of my next session with you guys, or practicalize it even before that session. Configuration data stored in text, exactly. When you go into the bin directory, go into the USR directory, you will see different configuration data handling different processes stored as text. So yeah, that's it. I think I may come back to this, guys, briefly. So let me just move on. I'll come back to this, guys. I'll open my WSI just to give us a hang of what we are talking about here briefly. Linux architecture. So this is the basic architecture of a Linux system. We have the hardware. We have the kernel, which interacts directly with the hardware. Then we have the shell, which acts as the interface between the user inputs and the kernel. And we have other programs, applications, compilers, date, grep, CD, VI running, and different users probably writing into the same Linux architecture. But this is the basic Linux architecture. Users interact with the Linux kernel by sending what we call system calls. We call it system calls. So when you invoke a command today, when you run a command today, your shell sends it to the kernel and gives you a response. But that particular process of invocation and sending that request is what we call system calls today. And also, we can do a little finding on what we call system interrupts. I need someone to explain to me what system interrupt is in the next session. I know what it is, but I want you guys to also think of system interrupts in terms of our system interrupts. Probably I would have loved to go deeper into operating systems, but let me just summarize this. System interrupts and system calls. Someone look into system interrupts outside this lesson. So the Linux operating system is composed of 4 major subsystems, like I've just shown us: the hardware, the kernel, the shell, and the user interface. User program application that needs to access the hardware use the services of the kernel. So as a user, you're sending a request on the shell, but the hardware uses the kernel uses the service of the hardware, which means that if you want to write files into a storage, you want to read files from the storage, you are sending the command through the kernel, through the shell to the kernel, but the kernel is going to read out the content of whatever you are requesting for, the resource you're requesting for from the hardware. So these programs access the kernel through a set of functions called system calls, like I just mentioned. In Linux, shell is a command interpreter that handles the outer part of the operating system. So it is the interface between user and kernel. So there could be many shells around the system, but there is only one running kernel. So I can open 5 terminals of Git Bash on my local Windows machine, or I can open 5 WSL Ubuntu terminals on top of my Windows machine. Any call I send today is still going from all 5 at the same time. Is still going to get to the same kernel. That I'm opening 5 terminals does not mean that there are 5 kernels now available. No, just one kernel. So the process by which a Linux system handles different requests or different calls to it is where we talk about system interrupts. But again, I don't want to talk about that. Someone go and look into system interrupts. It's probably something we should start the conversation for our next class. What we call system interrupts. So yes, kernel is the core component of the OS. Again, it was clear in the diagram of just now that kernel is the core system, is the core of the operating system. So yes, kernel is like central because again, the users are interacting with the shell, and the shell is sending the request down to the kernel and the response back to the user via the shell. So again, it's literally what is on the architecture. It interacts directly with the hardware and provides low-level services to the upper components. So again, the lower component is the hardware. So the kernel talks to the hardware beneath, gives the responses of those services required by the user, gives those responses back to the user. So the kernel is loaded into the memory when the system is booted. It communicates directly with the hardware. I've mentioned that before. So hardware controllers. This is the hardware part when I talk about storage just now, memory, hard disk, and the like, CPU and the likes. So the hardware, this is the parts that the the kernel interacts with. So an infrastructure is available, a storage infrastructure or a CPU is available, but you don't just expect the kernel to talk to the CPU directly or the CPU chip. So there's a controller that makes that communication possible. That's what we call the hardware controllers. So is these controllers that make it possible for the kernel to interact with the hardware devices of the Linux system. And spoiler alert, system interrupt is more particular to Windows machines, but you need to find out what it is. Yeah, so that's pretty much it on Linux. So as we move further, when we deal into containers, we will come back to this diagram here, where we'll talk about how containers abstract the hypervisor level of a virtual machine. I mean, how the hypervisor level of in virtual machines is abstracted in the container environment or in the containerized environment, and how that cuts down costs and management and memory management and even more efficient memory utilization. So that is a lesson for another day because we've spent way over 40 minutes, probably going to an hour that we've spent. Yes. So again, honestly, we would need DevOps would always need more time because it's way more. So we always try to get people abreast with the new concepts, and it takes time to do that. So we always need more time. So that's why I mean the first 40 minutes was not enough for us. So we have to then deal deeper into this just to finish an introductory session. Well, thank you for listening, but let me just quickly show us something. Let me just quickly show us something. There's something I want to show us. Okay. So give me a moment. Let me share my screen again. So let me know when you can see my screen. So I want to talk about so this is my WSL Ubuntu. I have it installed. So I have another OS. I mean, Windows subsystem for Linux is more like it's an OS on top of what's it called? It's an OS on top of a Windows operating system. So this is a Linux environment where I run basically Linux commands. PowerShell commands will not work here. CMD commands will not work here. So I was telling you something just now. Everything is a file. So you can, if you notice, you will see that my current like user is located on this directory. This is a file. I can go back to the base directory and delete my directory. That means my user is gone. And if I want to come into Ubuntu again, I would have to reset my user. So let me do an ls here. I don't have much because this is not mine. This is a different laptop. I don't use this laptop. This is a new laptop that I've not really dealt into. Some of my files have yet to be migrated. But well, let me do this. Let me do a PWD here. So you see, this is the directory structure for my current user. I can do cd/etc. This is a directory that handles configuration. Like we mentioned initially, that configurations in Linux are stored in text. So not every configuration. So you see different text file here, a .com file, a .conf file, and the likes. So I can decide to say, okay, let me open this .conf. This is not text anyways, but I mean, it's readable in text format. I can just say code casets.conf, and yeah, I'm going to have it opened in, okay. I've not installed VS Code on this part of my operating system, but I have it on my local. But let me open Git Bash. Everything. So Git Bash gives us the same experience as a Linux environment. So let me do an ls here. So I can say ls. I want to grep by, so I have one of my repos. Let me grep by, what's it called? Let me grep by E. Grep by E. So It's going to grep anything that has E in front, but let me grep by a specific. So this is me chaining two programs together. Like we mentioned here before, ability to chain programs together to perform complex tasks. So this is me chaining two programs together. So let me even go further and say, okay, let me count how many numbers of this occurrence. Again, this is of this particular of these attributes, the attribute of this. So chain programs together is more like the attribute of this command becomes the input of this one. I don't know if you understand. The attribute of this first guy is the input of the next guy. And the attribute of the next guy is the input of the last guy. So I want to count how many occurrences of E wardrobe exist. I think so this is just a simple environment. I can have a server that has so many files and I cannot iterate over those files to search. I just do grep. So it says it's only one occurrence. Just one occurrence. So this is me chaining commands together, chaining programs together. The input of one is the output of one is the input of the next one, and the input of the output of the next one is the input of the last one. So yeah, so that was it. So I've opened this .conf file. Yes, and it's opening the .conf file. So let me see. So this is the .conf file of my WSL Ubuntu. So one thing, so again, Linux is control. You have total control, especially when you are the admin. So I can decide to cut that particular file instead of grepping, cut it and cut out the part that has what I need. Let me say grep by the line I just copied. So let me grep by this. Let me see what to give me. Mozilla. So there are like 3, 4 inputs that has this particular prefixes. So it should give me the attributes, the whole 4 when I decide to grep. So exactly to give me the whole 4. So I don't want to read through the whole file. So the attribute of this cat command, if I do a cat, it's supposed to display everything, but I don't want to see everything. I just want a specific portion. I just want a specific portion. But if you want to see how everything displays, I can do that. Can display everything, but I don't want to see everything. I just want to see a specific portion. So input of one command, output of one command, the input of the next command. How's the summary behind that? So there's a lot of things. I mean, you have to get used to Linux and again, so well, so I don't take our time too much for today, so that we can go over and probably before I share you the text file. Sorry, I need to show you guys this text file. So you guys are going to, these are the requirements. You guys are going to install Oracle VirtualBox, Git Bash. I have Git Bash on my local. I do have Git Bash on my local. So let me just install Oracle VirtualBox. So I also dropped commands here for you to install. You have to install Chocolatey first. So you go to this URL to install Chocolatey and open Windows. You know how to open PowerShell as administrator now. So PowerShell, open it as administrator because it requires administrator level access to install. Open as administrator and you're good to go. So so let me try and install what's it called, VirtualBox as I'm talking with you guys. Where is the commands? So if you want to install a specific version, you use this command in brackets. So you guys are going to set up several things. Set up Vagrant. I mean, setting up Vagrant is just Choco install Vagrant and you're good to go. Once that installation happens, you move on to the next. Install JDK, that's Java Development Toolkit. Maven, IntelliJ, text editor. I mean, you already have a text editor on your laptop, which is Notepad. I do have one. Then you also need some accounts. You need to open a GitHub account, a Docker Hub account, a domain registration. Don't worry about this one. GoDaddy is cost intensive, so forget about the domain registration guide yet. Forget about this for now. Sonar Cloud code quality. I mean, this is what you need for CI/CD. So if you are to provision a Jenkins instance on the virtual machine you've created on your local, and you want to connect that to a GitHub instance to run builds on it, I mean, you need all this setup. So if you're able to set this up on your local, I mean, you are one step into it, like you are getting better at DevOps. So you have to just do the setups, even if You don't have to use everything, but you eventually have to use them, especially when you get to a business environment. Then set up an AWS free tier account so that you can be able to provision EC2 instances. But be very careful. You need to always scale down your instances when you are done because it's cost effective. It's very, very expensive. It's in dollars anyway, so 50 yen in dollars. Also, I need you guys. So you guys may be asking, which application do I even play around with as a DevOps engineer? So just go to GitHub and clone this repo. You will see an application you can play around with there. You can see application I play around with there is a Java project because you can see a pond.xml here. So you know that it's a Java project. So you can play around with the project and do anything you like. It's an open source project. So it's just for trainings. I will send more if you need more. But this is the first thing you need to do before you're able to install those guys in your local. Then for Vagrant Cloud, the virtual machines, this link you can use to access and provision virtual machines in your local. So remember, you're setting up Oracle VM, Git Bash, Vagrant, and after setting up Vagrant is you use it to automate virtual machine installation and provisioning. So yes. So, but even before that, so let me just try and do this guy. That's why I just copied and pasted most of the commands. These guys, you need to do them manually yourself. If you have any challenges, you can reach out, or better still, use an AWS documentation. Literally go to Google, how to set up a free tier account. You will see an AWS documentation for it, straightforward. But if you still don't understand documentation, feel free to reach out. Don't know if that makes sense. So let me do choco install virtualbox-y. So I have Chocolatey installed already on my laptop. Anytime I pick up a new laptop or I pick up a laptop, the first thing I do is install Chocolatey because that's what I use to install everything. So for Mac OS is Brew, Brew, like brewing beer or whatever. So for Windows, we have Winget, we also have Chocolatey. I prefer Chocolatey. So Choco install VirtualBox -y. So if you have any questions, you can start unmuting and asking now. So I'm installing VirtualBox on my local. And I already have multipass on my local, but I have different virtual machines, multipass lists. They are not running anyway because I'm not using them. So we have Control One, Ubuntu. These are different virtual machines images. So, but for the purpose of this lesson, please use Vagrant and Chocolate. So if you have any questions, please go ahead so that we can go and have a restful evening. Are you guys with me? Oh, the lesson was very, very explanation and very straightforward. So I agree. So,
Hello.
yeah, I can hear
Hello.
you. I can hear you.
Yeah, thank you for the lesson. But the way you were going with the installation, with the direction of the installation is it's a bit faster for me. So I
Faster?
don't know. Mm, there are some of uh the links you are talking about. I don't know. Are you going to share
Yes, I'm sharing it. I'm going
the
to share it.
file?
I'm going to share it.
Okay, okay. The file will contain the procedures like the what we'll do first and as into the
Yeah.
last.
Yes, essentially. So I will just share you the whole document of everything you need. So required documents, so local development tools, what
Okay,
you need to install. I'll just share it for you. Let me just copy and paste. I was thinking I'll be able to share files on this chat, but it seems I can't share files.
okay. We'll see it on WhatsApp or
Let me just drop it on this chat. Oh, there's a limitation here also. To better say,
yeah.
I'll
There's
send it to Bright.
limitation.
I'll give it to Bright to share. I'll drop it on the chat.
Okay,
Drop it on
okay,
WhatsApp.
okay. Because we'll need that, sir.
There's a limitation of 2,518 words. That should not be a thing, but I'll share it on chat. I'll share it on chat.
Okay,
If you have any challenge, first thing you can do is just go to Google and type and browse. But if you have, we're always available to help. At the least, at the most, once we
okay,
are available, We are good. Where does Terraform fall under? Infrastructure automation. Infrastructure provisioning. Oh, okay. This is February 1. Oh,
So
that's
I have a
it.
question.
Yeah, please go ahead.
Yeah. Okay, so what if I have my environment set up already?
Then you are good to go.
Like I have my virtual box already. I have an image, so I have my Ubuntu image installed on it. Do I need to go through Vagrant again?
You don't need to go through Vagrant, but we are just trying to show you a better way or an easier way to provision VMs. So currently, how did you install your virtual box? You went to download the virtual box dot executable,
Yeah.
right?
Yes.
Exactly.
So
So
I have the Oracle Vanilla box there. Yes.
you downloaded the executable on the web browser, right?
On the web browser, yes.
Exactly.
Then
So we are just so the point is you are trying to make everything, they will say people like terminals a lot and the likes, but again, it's fine. But it'd be nice for you to have Vagrant so that you can experiment so that you can use Vagrant to set up like 5 virtual machines on your one laptop and just provision
okay.
it, just have the experience. You get,
I did it
yeah,
now.
good to go,
Yes.
fine. You're good to go,
All
fine.
right.
But if you don't use Vagrant for it's good. You can use multipass. You can use
Okay.
Vagrant, anyone you want, but they're all available for you to choose from. But the goal is understand the
Oh,
concepts, understand how we are going to
oh,
leave virtual machine provisioning and enter containerization soon. You get, it's just
yeah.
at every DevOps road, should I call it road milestone, we try to implement what was done or what is done on that milestone because it's not useless. It's still being used. Like I said, virtual machines are provisioned today. So yes, that is it. So it's very easy. So if I go up now, you see Oracle Virtual Box recently added. So that's it. Just for my terminal, all that is done. So I will share the text file. I'll share the text file. I'll share the text file. So, and do not be afraid. It's just as easy as it is. It's the same way it just installed in our short conversation. That's how easy it is. More questions, please, or we can call it a day. So you can see my virtual box is up. Now, ideally, before I would go and do ads or go and import an ISO image that I downloaded to my local, probably a 1 gig or 2 gig image, import it and come and put it here and put it here. Instead of doing that, I'll just use Vagrant. I'll just do Choco install Vagrant. That's the next thing I'll do now. And I will install Vagrant and I'll use that Vagrant to initialize different virtual machines. But we won't have time for that currently. And so that's what I said. Just start from here. These are the basics and you'll get there. We'll get there. If you have any questions, ask. Please, more questions, please. Who are my people? Who are my people in the meeting? Oreoluwa, Nwamaka, Faith. I want to hear from you guys. I think you guys were in my session last week. I didn't hear your voices. Please introduce yourselves. Thank you. Ali Damola, please go ahead. Okay, you guys are shy, Abby. It's fine. It's fine. But you can drop a message on chat. But please, do not hesitate to ask any question. Oreoluwa, you're muted, right?
Oh, good evening, sir. But I think I'm cool with it for now. I don't really
Okay.
have any question.
Great, 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 great. Uh, Daniel Ali Damola, please go ahead. Thank you, Oreoluwa. That's it anyways. I mean, we don't have so much. So Linux is large. Virtualization is a big topic. What I did today is just summarize. That's pretty much it. Summarize. Linux will still continue with Linux. I don't want us to let go of Linux so easily. So we'll still continue with Linux. Who else? Still continue with Linux. Fine. Okay. Faith. I've not heard from Faith. Oh, Onwamaka. Oh, they are running away. But don't worry. We'll meet. We'll see in the next session. So I will try and drop this requirement.txt file on the chat. so that we can just install and play around with it on ourselves by ourselves. All I want you AWS setup. You can set up a free tier account for
Yeah.
yeah. You
So
can
I
set
have
up.
AWS and Azure. So
Yeah, good. So you are good to
yeah,
go. So you can decide to go further by either. I would say don't set up an AKS cluster on Azure. Just try and set up a cluster, a Kubernetes cluster. Probably when we get there, shall we get there. I'll tell you to use a different tool to set up a Kubernetes cluster. You can use Kubernetes operations tool or KubeADM. You will not be using native. You will not be using the native cloud platform solution for Kubernetes. But we'll get there. We'll go deeper. Go
okay.
deeper. Yeah. That's all. That's all. In the absence of any more questions, are you asking a question?
Oh yeah, no, there's a problem.
I can't hear you. Okay. In the absence of any other question, I'll say good evening to you all and have a nice weekend. See you next time.